Okay, so now we're going to combine our systems of equations with inequalities, which we've done before, and hopefully it's going to make a lot of sense that when we combine them, there's going to be systems, so we're going to have more than one line, and inequalities, which means we're going to shade, and if we have two lines we're shading, then there's going to be a place where they cross over, and our solution set for inequalities is going to get a little smaller because it's going to have to be where two lines cross. You'll see what I'm talking about. Okay, so let's go to Miss Bailey's party and think about her fruit salad she's making. She's spending less than $10. And here's the cost of the grapes and apples. And she's buying at least 4 pounds of grapes and apples. So let's define our variables. I was looking at the graph below. It has apples on the y-axis, so let's say y equals pounds of apples. X equals pounds of grapes. So if we're talking about the cost of the fruit, she must have spent less than $10. So I'm going to have 2.5 times x plus 1 times y, and that's going to be less than $10. And then for fruit, I know that x plus y needs to be at least 4. That's going to be bigger than 4. Okay, so these inequalities represent a system. So we're still doing the system. So let's solve the inequalities for y. The one that's the cost is going to be y equals, or nope, it's not, y is less than 10 minus 2.5x. And I'm writing it backwards. So you could also write negative 2.5x plus 10. And the other one with the pounds is going to be y is greater than or equal to 4 minus x. Bad minus. Okay, I went ahead and graphed the lines so I could make nice straight lines that made sense. So the blue line is the cost. And it's 10, starts at 10, that's the intercept, and it's got a slope of negative 2.5. So it's going down $2.5 for every pound. So, and it's less than, so that's shading in everything on my graph that's below the blue line. My other line starts at 4 and is going down by 1. It's got a negative 1 slope, so it goes down 1 over a pound. Notice that I went over to the 1 and not stopped at the 1.5, which is fine. Okay, so since that one is greater, my red line, I'm going to shade everything that's above the red line. And I'm tempted to change my color of my pen to purple because this right here is my solution set. My solution set is in between my two lines because one is greater than, it has to be greater than 4 pounds. So this is the line, boundary line for above that. And then the blue is my boundary line right here and everything below that. One of those should be dotted. The blue line should be dotted. So the blue line, we can't have anything that lands on the blue line, but it could land on the red line. So let's think of what the possible combinations are going to be. They have to be greater than the red line. So we could have, if I have, remember grapes are on the bottom. If I have 1 pound of grapes or apples, which are y, okay, if I have 1 pound of grapes, I have to have at least 3 pounds of apples. Or I could have 1 pound of grapes and 4 pounds of apples. Or I could have 1 pound of grapes and 5, 6, or 7 pounds of apples. Or I could have 1.5 pounds of grapes, and remember anything above that red line, I could have 4 pounds of apples, and I'm still in that shaded region. I could have 3 pounds of grapes, and I could have 1.5 pounds of apples. So I'm really looking for anything that's inside this little pie piece, which is my solutions. So there's lots of combinations of grapes and apple weights that I could buy and still have it cost less than $10 and still have it be at least 4 pounds. And if you look at the numbers I picked, 1 and 3, 1 and 4, 1 and 7, 3 and 1.5, all those are more than 4 pounds, which is one requirement, and they all would be less than $10 if you worked it out. So then you're supposed to decide which solution you would recommend, and you have lots of options, and you're going to have to decide. I'm thinking I would pick something close to her maximum amount of money and close to like even amount of grapes and apples, but or pounds of grapes and apples. I don't know her recipe, so maybe I wouldn't. But you go ahead and put in a solution for what you would recommend, and I'm going to ask you tomorrow. Okay, now let's look at points that are solutions or not solutions. So just like when we did one linear inequality, we're going to have to look for ones that are in this dark shaded area. So where the two shaded areas cross, that's where our solutions are. So if it's not in this area, it's not a solution. And in this case, a solution could be on the line because both lines are solid. Solid lines equal solution. Dotted lines, no. So 0, 0 is not in my solution set. It's in this one, but it's not in my other one. 2, 2 is on this line right here, which is actually in both solutions. So this one is a yes. -1, 4 is a no. It's not in both shaded areas, the double shaded area, the dark shaded area. D, 4, 1 is in that shaded area. And -3.5, -1.5 is not in any shaded area. So hopefully that makes sense. We has to be in a shaded area for both of them. So this line right here would not be solutions. This line right here would not be solutions. This line and this line would be solutions because it's in where both of the shades meet. If you're looking for a solution, excuse me, and you don't have a graph, you can always substitute in the numbers into the inequality and see if they come out true. So let's put -3, 6 into this inequality right here. So I'm going to have 3 times 6 greater than or equal to -6 times -3 minus 9. So I have 18 greater than or equal to 18 minus 9. So that would be true because 18 is going to be bigger than 9. In the next equation, we have 6 less than or equal to 3 times -3 plus 6. Is 6 going to be less than or equal to -9 plus 6? The answer is going to be no, because -3 is not bigger than 6. So no, it is not a solution. It meets one, but not the other one. On 10 and 11, I went ahead and drew the lines in because I can make them straight and neat that way. So remember, y is hoi, so that's my horizontal line. X is vux, that's my vertical line. So this one right here is y less than 1, so I would shade underneath. X is my vertical line, so this one is x less than 1, which means I'm shading to the left. So my solution is going to be in this bottom quadrant 3 and a little bit more. But I can't pick a point on the line because they're both dotted lines. So I could pick -1, -1 would be a point that is a solution to my system of inequalities. All right, number 11, here's my y less than 3 because it's a Hoy. I need to solve this one for y. So I end up with 4y greater than 12 minus 8x. And I divide everything by 4. And I end up with y greater than 3 minus 2x. So there's my boundary line is right here, the red one. And for my y less than 3, I shade in down here. And for my y less than 3 minus 2x, it's greater, so I'm shading over here. So my solution set is down here. And a point in that solution would be 5, 0. You can pick any point that's within that double shaded green and purple area. Okay, look at number 12. So explain why the point where the boundary lines intersect in the system is not a solution. So that's going to have to do with where the lines intersect, right? We're talking about, whatever's shaded. We're talking about the point where they intersect. And why would that not be a solution? Because one of your lines will be a dotted line. And if a dotted line and a solid line intersect, it's not a solution because the dotted line wins. So it has to be two solid lines for it to be a solution, and it's not going to be two solid lines. Okay, now we're going to write the inequalities for these graphs. And remember, we write the boundary equation, and then we do the greater than, less than, greater or less. So I'm looking at let's do this one first because that's the easy one. It's a Hoy. So I'm going to have y and 3, and it's shaded less than, and it's dashed. So it's going to be less than 3. My next line, I'm just going to be a color changing fool. Okay, my next line right here is going to be, it goes through 1. The slope is positive, and it goes, up 1 over 1. Okay, so it's going to be x. It's solid, so it's going to be equal to, and it's shaded above the line, so it's going to be greater than or equal to. Okay, I'm just going to do my solids in green this time. So I have a negative slope, and it goes through 3. So I have plus 3, and my slope is -1. And my y is going to be greater than or equal to because it's shaded above, and it's solid. But it has a negative slope. Okay, and then my dotted line, it goes through -3. So it's going to be -3. The slope is positive. Looks like it's 2 over 1. So I'm going to have 2x. And it's not going to have the equal to sign because it's dashed and it's shaded also above, so it's going to be greater than. So those are my two lines. Hopefully you can see why. You can see the shading and how the dotted line works. Yada, yada, yada. Okay, again, I drew the graphs. These are both already solved, right? This one is Vux. So here's my vertical line. It's less than or equal to, so I'm shading over here. My other line starts at 5 and goes up 1/2, and it's greater than or equal to, so it's going to be up here. So B would be the only point that's where they're both shaded, which is what we're looking for. And that's it. So we're graphing inequalities, shading in above or below, but we just happen to have two inequalities at a time, and we're looking for the place where they're both shaded, where the shading meets, where the shading overlaps, and that's where our solutions are. So hopefully I went slower this time because I was really trying to not rush it.